Hi everyone. Hi everyone. Welcome back to the channel called Engineering Beyond Blueprints. I much appreciated for the feedback on the last video. There are few students and few of the followers are requested to talk about what is mean by component engineering role and how it is important for the current industries. So I would like to start with today to talk about what is component engineering role and what is the major role they would play in all the different industries. So here is what I want to break down this component engineering role into multiple parameters before I get into that. So one is I talk about as a component engineer, first we need to understand what is the requirement for a given product or given design, and next comes into the component selection. So component selection is again like important parameter when we design board or mitigating the obsolescence issue or not. So third thing is comes for qualification process. So we as a component engineer very much engaged with design engineers, supply chain management and so on, right? So next part comes into the documentation. So any activity that we do or should be recorded somewhere, right? So any design engineers or any manufacturing engineers or even manufacturing plants, they should know what is the documented and who are the signer for this selection of the new part numbers or mitigating the obsolescence part numbers. So next one is comes into the design and manufacturing support. Yes, we do the documentation. Does it really kind of helpful to the manufacturing team or the plant who make the final product from the manufacturing? And fourth comes into the sustenance engineering. In this sustenance engineering, we are talking about only the obsolescence, how obsolescence is getting triggered from the different vendors and how do we can address that. And next comes into the risk and compliance. So always whenever we do select the different set of component, right, so we should know what is the risk associated with that component and how do we tackle that and how well it is compliance with different industry standard grade. So this is how I would like to break down this session, and I want to walk through on when it comes for requirement analysis as the first topic. So requirement analysis is basically a it's a set of capture the system level requirement. Basically it indicates electrical, thermal, EMI, EMC constraint and derating guidelines, because any components, right, it get derates over period of time. And next talking about AEC Q100 and AEC Q200. And basically here is, if you ask me, AEC 100 is for purely for integrated circuits as a requirement standards, and AEC 200 is for passive component. And there are some mill standard grades that we follow, and ZDEC and IPC. ZDEC and IPC is global standard organization which across the industry come collaboratively and build those standards when they manufacture any given component. So this is a pretty much good brief summary about requirement analysis. When it comes for component selection, right, so any component which we select, we understood at system level, okay, this is the requirement. On system level we have to break down into component level. We have to see what are the parameters is required to be analyzed which required to the design spec. So that is a topmost priority when it comes for component selection. Along the side we need to understand what is the component life cycle, how long this is available in the market. If it is suddenly got obsoleted or NRND or decline in the near future, then we need to see is there any easy way to find a solution which is substitute over a period of time, right? And then next comes for cost and reliability. So as I talk about in my previous video, cost is important parameter because we are selling the product. Any BOM cost directly associate with the selling price of the product, which including operational, capital investment, plus overall design requirement, whatever. This is combination of base, right? So any component cost is delta of getting change is impact at a bigger level. So that is what we need to keep in mind when go for component selection. Now come for qualification process. See, in many industry, what happens when it comes for qualification, right? We need to understand what are the electrical validation testing is required, and what are the thermal stress. Basically, in the thermal stress, we have all testing and uh, HTOL testing, we can say, and another one is HAST, and other one is called HALT. So these are the three different testing which significantly is required when we do any kind of process qualification, right? So why we called HTOL testing is required? This is called high temperature operating life. So in given reliability testing, it specifically in semiconductor device, right? We need to know when we design and stimulate at extreme temperature whether it can be withstand or not. So that is what we do in this particular testing. And next come for HAST testing. HAST testing is kind of at extremely high temperature and at humidity condition, simulating, escalating, aging the potential failure of the component. So this is basically we used to understand at extreme temperature and extreme humidity condition how the component behaves. Right, at system level there is a different specification we captured at system level. So that is how it is going to behave at a system level. That is what we do in this testing. Then next comes for HALT testing. So HALT testing basically we use to understand how product is reliable, how long that can be withstand given the stress analysis, right? Any product it go for stress analysis. So during that time, HALT testing is a very much preferred testing is expected by the customer, which we sell this product in called aerospace industry or any healthcare industry and so on. So next comes for mechanical reliability testing. That is again stress analysis we do how it is impacting at mechanical component basically. So last one is nothing but EMI and ESD testing. EMI is like electromagnetic interference and ESD is called electrostatic discharge. Any near component, right, in the given board or in the what happens one another components getting impacted with this magnetic interference. So basically we need to understand how this is bigger creating a problem at a system level. So these are the pretty much testing is required when we do the qualification process. So next comes for documentation. See, these are the testing we talk about. We talk about system level requirement, we talk about part selection, and these are all required to be documented somewhere, because as a component engineer, yes, you done a lot of great work, but it's nowhere you know captured. So documentation play a vital role to say yes, this is what we aligned and this is what we signed off as a document, right? It's including drawing updates, symbol, footprint creation, or the component is ROHS or non-ROHS, or it's approved vendor list in aerospace industry or any given industry. So that is what we do in this case, right? So this is a pretty much required part of documentation. So next comes for design and manufacturing support. Yes, we kind of build the system. So after build the system, what we do, like there is a different set of components go along with that. When I say different set of components means it could be a cable harness, or it could be a mechanical fitment as rack mount or so on. So we need to understand at a system level, right? So we're not talking about only the part of the system, but we have to think in a bigger. So how this can be assembled in a customer place. So that is what we need to understand, how we are ready to manufacturing support over a period of time. For example, when it comes for warranty or support for service and repairs, right? So we need to keep this document handy so that it is not going to impact in near future. Next comes as a part of decline space, right? We talk about in our previous video, sustenance engineering is again like a critical role play across the industry. So sustenance engineering basically we do understand, track the record of each supplier who supply these components. They should be an issue the part change notification or product part discontinuation notification basically. So they will announce through by issuing the notification to the component engineer saying that okay, this component getting obsolete near future, with XYZ reason. It's always not necessarily to be a obsolescence. This could be uh, a manufacturing location change or whatnot. So those are the impacts that we need to understand, as a part of sustenance. So next we have to check the supplier health. All right. So when we select any component from the particular supplier, we need to see how long the supplier can build this, how it is competitive in the given industry, and how this can be sustained for next 5 years. So that is what we need to do as a sustenance engineering. And again, one last thing we don't want to miss, that if the part is gone obsolete, so obviously keeping in mind, we should have the drop-in replacement to avoid any kind of redesign process which is costing more for the company as well as for the resource engagement. Next come for risk and compliance. This is one of the important parameter which we don't want to miss, because this caters an issue at a customer place, and it could be a revenue impact in near future if it is not documented or if it is not identified well in advance when it comes for risk, and whether it is compliance to the system level, from part to system level it is compliance or not, that we need to check in this forum. So what we do basically, so in this risk, right, sometime what happens, assume that you one of the part number gone obsolete, right, and you don't have any supply from the original supplier, right. So always sometime we have to find as a mitigation strategy, we'll go and approach to the counterpart, like broker buys basically. Those are nothing but refurb component which is extracted from the systems where they have been sending it for send it out for scrapping. From there, these are the critical components they extracted and tested, and make sure that okay, it's a counterfeit part, but we have done the minimum testing on this component, and they as a broker they will certify. So that certification requires approvals from the customer as well. When we make a product, we should notify us we bought this part number from the counterfeit, and this is still feasible with the given reliable test reports of the component. So next comes, we have to do auditing for the suppliers. When we select any kind of brokers, right, we need to audit. So any broker, if you are buying, so we need to audit before we adding them in our system to buy as an authorized. So given that said, right, the story is again never ending here. So it has to be move on, and we need to see how big this component engineering role in across industry, and there is a lot more to come our way to discuss on this topic. And I want to talk about more on the active component on the selection process, and I want to bring a lot of topic which is very much hidden in some of the expertise mind. So I want to break this out, and I want to bring my expertise into it, and I want to say, hey, here is the niche note that can help you to grow in the industry. It's given any industry as a component engineer role. So with that said, I hope this video helps a lot when you trying to understand what is the role and what is the significance of component engineering across a different industry. Thank you so much and have a great day.